Hello and welcome to Grade 10 Applied Math. We are in Unit 3, Quadratic Relations, in Chapter 6, Lesson 3, Key Features of Quadratic Relations. By the end of this lesson, you will be able to describe and identify key features of quadratic relations. If we look back at what our last lesson asked us to do, it was to graph, using a graphing calculator, to graph the following, to graph data, and here we have another example, and then we can determine the equation of the line of best fit. So let's go to our graphing calculator. Okay, so we want to take this table of values and put them into here. So remember how to do that. So we press on this plus sign, pick a table, and then we put in these numbers. So we have, in the x column, we have negative 15, negative 5, 5, oh, not negative, okay, 15, and 25. In the y column, we have 9, 4, 1. And now, this is what you'll notice over and over again about quadratics, that it's, in this case, it's decreasing, and then you're going to see a repeat of the numbers. The 4 and the 9 come back. Now, this shows us some lines here that are coming, and we're seeing them. You can zoom out a little bit, and you can see the starting of a parabola. Now, here's the important part about getting the curve of best fit. So we have to make this regression, we called it. Okay. So again, we need to use regression y approximately a x1 to the power of 2 plus b x1 plus c. So we're going to type that in here. Once you type it once, you can leave it there for a while, and then you can just replace the numbers, and it becomes easier. So I'm just using this keypad that Desmos gives us, and then bx. Don't forget the 1. So the 1, I've actually made one mistake here. On the y, we need to have a y1. So let's put that in here. There we go. Now, hey, all of a sudden you do that and it recognizes it all. And we just have the C to put in. And the reason why we're doing this is two reasons. It is going to show us what the curve of best fit looks like. You can zoom out so you get the full view. But it's also going to give us the A and B values. So look at these numbers here, right here, down on the left bottom corner. They're going to give us the values. So here we know that A is, and I would round these numbers. So A is 0.0186, let's say. B is negative 0.186 as well. That's interesting. And C is 2.15. So a few things to point out. The fact that A is a positive. It's positive means it opens up. It's a small number, I mean like a decimal. Okay, that means it is wide, very wide, not opposed to narrow. B doesn't tell us a whole lot, but C tells us the y-intercept. Okay, so if we were to zoom far in, we would see that it's 2.15, just over the 2. Okay, so that's actually interesting to know for this lesson today. Okay, so could we have an equation? Yes, so therefore, equation is y equals 0.186 x squared plus, no, well, it would be a plus, but we actually have a negative number here. So negative 0.86x plus 2.15. And that's as simple as it could get for you to turn these types of questions into an equation. The numbers look complicated, but it's all relative to this Desmos program coming up with the numbers for you. So if you can follow a graph, make the right regression, green. All right, so there we go. So let's put that aside. And now we're going to talk more about these parabolas. Okay, let's continue now with our definitions. So now it's time to look at some key features of the parabola, this U-shaped. And I just took this bigger picture and inverted it. You'll see the numbers don't make sense, but I wanted you to see that it can go upside down too, and your parabola can face downwards. So first thing we have is the vertex. And so the vertex is the point at which the parabola changes from decreasing to an increasing, or from an increasing to a decreasing, aka the turning point. Okay, or maybe you want to call it the peak. Not speak, that looks like the S. The peak, or the bottom. Okay, so in other words, at this point, we're going down and we peak, or we bottom out here. On this one, we peak. Okay, so this is now going to be called the vertex. All right, so the vertex is the point. Now the other thing we can say is, well, what is the vertex? So the vertex is -3 and -4 in this case. We won't bother on this one, it's too small. Okay, so we can say vertex is -3, -4 if we're asked this question as a question. So you'll get different parabolas, and then you'll have a series of questions to answer to point out. The next thing is this a max or a min? The highest or the lowest y value on the graph. The y value of the vertex occurs. So it's y equals something. There's no x. So you're really just grabbing the y of the vertex. I might as well do this. Let's say our numbers were not inverted. We would have 3 and 4. Okay, so in this case, but we're really only focusing on this main graph over here. So the max is where it bottoms out. So here we have a minimum. Okay, we have a minimum of y equals -4. It's only the y value we're worried about. This one is a maximum. Y equals 4. So really not hard. You're just picking the number from the vertex. Okay, and Notice a parabola is very important. They cannot have both. A parabola can't have both min and max. Because in a upward opening parabola, it has a minimum, but these lines up here go on forever into space. So there is no max. And then here we see, like, we kick a ball and the ball goes up at maximum, hits a maximum height, and then goes down. But these downward lines go forever. There's no minimum. So you can't have both. You have to have a max or a min, and it's basically the bottoming out or the peaking. Okay. An axis of symmetry is the line that goes through the middle of the vertex. Okay. Okay, so we have our axis of symmetry. So what is this then? It is axis of symmetry, and sometimes we just short form say AOS. Okay, so this is also axis of symmetry. And what the word symmetry means is um, everything to the left mirrors everything to the right. So the axis is also, that things revolve around an axis. So if you were to say the left side mirrors the right side from the vertex on, left and right. So we can also give it a x value. So x is x is equal to p. P is the coordinate of the vertex. So um, we'll have a number like x equals something. So in this case, the axis of symmetry is x equals -3. In this case, it is x equals +3. Obviously, they're similar parabolas. Okay, so that's one thing you'll have to show. Be able to pick out the axis of symmetry. Okay, last and very important is the x-intercepts. So maybe we'll pick a different color here. Blue works. Okay, so the x-intercepts are the x-coordinates of the points at which the parabola crosses the x-axis. We also call these, very important, okay, we also call these two other things, the roots or the zeros, okay? So if you're ever asked to find the roots of a parabola, they're asking you to find out the x-axis. Why are they called the zeros? Because they're at y equals 0. Okay, so here is one x-intercept. You remember x-intercepts from when you were graphing straight lines and where it crossed. So the roots, or their x equals -5, x equals -1. Okay, so again, these are called the roots, or they're called the zeros. Okay, x-intercepts. Where are they on this side? Well, right here and right here. So x equals -1, x equals 5 in this case, and that's acceptable. You don't have to. You can say that the x-intercepts are, that is, -5 and 0. Okay, and -1 and 0. So you can put it as a coordinate, or you can put it as almost like an equation, like x equals. All right, and that hopefully that makes some sense. 4 key things we need to keep in mind when we're dealing with parabolas. So let's go and we'll put this into practice in another question. So I want you to get really good at this, okay? So here's an example. For each graph, okay, identify the following. So A, the coordinates of the vertex. So the vertex, again, we want to find that, is way up here. Okay, so our vertex. Our vertex is, they're not giving us an easy number, but we are going by 2's here. So I bet you that number right here is 9. Okay, so we are going by 2's here also, so I bet you there's a 1 here. So actually, what looked like would be hard to predict is actually pretty easy. So we have a vertex of 1, 9. Okay, the vertex is a coordinate 1, 9. Next, it asks us what is the equation of the axis of symmetry. So remember, an equation of an axis of symmetry, must look like y equals something. So if we again do this and we look at where our axis of symmetry is, goes through the center. That's not a great center, but we see that it's here. It's at y, sorry, x. Y, it's, oh boy. Of course, it's x equals something, the axis symmetry. X equals 1 is the AOS. Okay? We'll put vertex. Okay, so X equals therefore the AOS is X equals 1. All right, what is the y-intercept? Oh, we didn't talk about that before. I don't know why. We talked about it in previous lessons. But let's say the reason why we didn't talk about it on this one was the y-intercept is right through the center. So it is something we will talk about. The y-intercept is where it crosses the y-axis. So let's just zoom in a little bit here. Okay, so our y-intercept, use a different color here, is where it crosses the y-axis. And that is at y equals 8. Okay, so y equals 8. Or it's at 0, 8, right? Good. So that could be important if we're talking about launching a rocket. Like how high was it when we started? We started at 8 meters and we launched it. Okay, is it a max or a min value? Well, it goes up and it peaks and then comes down. So we are dealing with a maximum. Okay, not a minimum. Okay, so therefore the max is, and we said we would put this as a y value of the vertex. So the y value of the vertex, y equals 9. And lastly, we have our x-intercepts. Our x-intercepts are here and here. So x equals -2, and you have 2 of them because the line crosses the x-axis twice. So if we did this with linear, we would say that we'd only have one place where a linear line would cross the y-axis. Sometimes we like to put it as, or put it as a point. Now look at your y values are 0 at that point because it's crossing that, that area. The y equals 0. All right, good. So let's see if we can do one or more. This is very typical of what you'll be asked to do. Okay, you are given a parabola, and then you're asked to identify all the key features. Okay, and we've talked about all those. The only other thing I would say is let's add one. Okay, um, or add two. I'm going to add two because, okay, direction of opening, shape of curve. Okay, so in this case, I would say direction of opening downwards. Okay, so look, it's opening downwards. Okay. The shape of curve, I would say, well, it's pretty normal actually. So I would say, is it narrow? Is it wide? Like our first example was wide. Or is it pretty normal? So is it narrow, wide, or normal? And so in this case, I would say it is normal. Okay, in this case. Just keep thinking along those lines of, so now we have a 1, 2, 3, 4, 5, 6 things to sort of, or 7 things to consider about our parabolas as we move forward. Okay, so this one again asks us to plot it. So it's handy to do this on our, by being able to do it by hand. Obviously, you can do it with your graphing calculator, and maybe it's worth doing that afterwards. Okay, so the shape of a small wooden bridge over a lake walker can be modeled by the quadratic relation y equals 25 minus negative x squared. Now we're used to seeing equations like this: ax squared plus by plus c. But they can look this way. Here's your c, here's your a, and it must mean that b equals 0 in this case. But none of that really matters. They even give us the numbers here, but we have to plot them. Okay, so what you do is you have to end up substituting these numbers. Now you can do it that way. So let's say we did negative 5 in for x. Well, we would have y equals 25 minus negative 5 squared. We have y equals 25 minus 25, because look, this would be a positive 25, but this would be a negative. Okay, and y equals 0. So now we know that. Okay? If we do the next one, this could take some time here. Y equals 25 minus negative 4 squared. That's going to be 16. So y equals 25 minus 16. Y equals 9. We put 9 in there. And we have to keep going. So y equals 25 minus negative 3. You see why you might want to use a graphing calculator. Negative 3 times negative 3 is 9. So 25. So it turns this to a positive 9, but there's already a negative symbol there, so it's negative 9. Same up here. Y equals 16. Okay, keep going. Now y equals, we're going to take up all the space we can use here. Negative 2 squared, y equals, okay, so negative 2 squared is 4. Positive 4 with a negative makes it negative 4. Y equals 21. Keep going. We're just going to keep using the space we are given here. Y equals 25 minus negative 1 squared. Negative 1 squared is 1. So 1 make a negative is a negative 1. Y equals 24. Okay, now y equals 25 minus the squaring 0 is 0 equals 25. I guess we keep going here. Okay, so y equals 25 minus 1 squared is 25 minus 1. Y equals 24. Okay, so now we see it start to rebound. It's now peaked at 25 and starting to come down again. Okay, so that's kind of important because that peak is telling us what? And think about that. That peak is telling us one of the things we're looking for. Okay, where the vertex is. So right away we know this is our vertex. All right, and we could keep solving these. Maybe rightfully we probably should keep showing all this work, but trust me, when it goes, it's going to just repeat the pattern. You can save yourself a little bit of time. Okay, so let's start then. None of our numbers are too far, like 25, although we are going to have to maybe, the highest we're going is 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can go 2.5 for every line, and it would get us there. So if this was, and that's hard, that part of the hardest part is like knowing how to scale your graph. Okay, and then we're allowed to go by ones here. All right. So we got a lot of blue out there. Let's get maybe a different color. Okay, so let's just start. What you do is I check them off as I go through. So at x, 0. Okay, at -4, 9. At -3, 16. Now, you could do this with your graphing calculator with Desmos and probably save you some time and worrying about graphing. But, it is important to have the skill that we can graph as well. So that was -124. Now we're at 0, 25. Now we start coming down again. So at 1, 24. And at 2, 21. And at 3, 16. And 4, 9. And 5, 0. Okay, very good. So when I graph these, I always start at the vertex. And I kind of curve my line downwards, hopefully hitting those points, and curve my line downwards. And it's not the idea that it's a tic-tac, like you're going from connect the dots. you want it to look a bit curvy through there. Okay, not perfect, but it's kind of hard with these smartboard pens. All right, so graph the data, check. Join the points with a smooth curve, sort of, check. All right, identify all the different things we need. So the first thing they're asking us to identify, let's go off by list here. The x-intercept, or we call them the zeros, or the roots. Okay, so these are going to be x equals 5, -5, and x equals +5. You can see them. You can see them right here. So we have 5, 0. We have -5, 0. All right. Next, we have the y-intercept. Okay, so that's going to be y equals right here. So, too bad I used a different color there. Okay, right here is the y-intercept. Y equals 25. Or you might want to put it as a point. 0, 25. Next, the coordinates of the vertex. And yeah, the vertex we write as coordinates. So they are at 0 on the x and 25 on the y. So 0, 25 is your vertex. All right, kind of make this all fit. And what is the equation of the axis of symmetry? So again, a little line going down the middle. Okay. The axis of symmetry is an equation. So it's got to be x equals something. In this case, it's 0. My smart pen is not working out for me very nicely right now. Okay, so again, some key points here. From the vertex, we can get the y-intercept, and we can get the axis of symmetry. We can get the max. And it doesn't ask us that. So what if we, other things we talked about. So just because I want you to be ready to answer all these. So is max or min? Okay, so what is this? This is going to peak. This parabola peaks at a max. Therefore, it has a max of y equals 25. Okay. What other things did we mention? It opens down. It opens down. I want to point out one thing. Notice that equation of a, the a value is negative, right? Then that tells us it opens down. The A value was negative. I mean, you can look at it, you just look at the graph and we know that it opens down, but the fact that the A value is negative also gives us a hint towards that. Okay. There's a worksheet that goes along with this, describing key features, and you'll be provided with that handout. All right, thank you for watching.